Hi, this is Jesper from Velocitypeak, and in today's X Particles tutorial, we're going to build these kind of tentacle bubbles. And we're going to use Redshift as the renderer. If you want to follow along, the project files are available on velocitypeak.com. Okay, let's jump in. Okay, so let's start. The setup is that I have a scene of 300 frames. I have some elements we can use later on for rendering and a few materials as well. But let's start by building the outer membrane. So let's go and add a sphere. And I'm going to call this sphere outer because we're going to have one more in just a few minutes. So let's take down the radius to 65. And I want to have a more even topology. So let's do icosahedron. And this should be smooth. So 96. So that should be smooth enough. And now I want to displace this. So let's add a displacer. I'm holding down the shift and adding the displacer. And the height, let's set this up to 18. And let's go to the shading tab and add a noise. And let's go into the noise. We can keep it at standard noise. Obviously, you can experiment with that and the seed. But let's do 450 for the scale. And I'm also going to switch the space to world. We won't see a difference now, but if we were to make a copy of this, you would see that this actually is traveling in world space now. So if I make another one, it would just look a little different because it's now living in world space. So well, let's delete that. Let's go back to the displacer. And I also want to add some animation speed. So let's see what 1 does. So that's too fast. Let's do 0.3. So 0.3 should do it. So now I want to be able to see inside of this sphere. So let's add a display tag. I'm going to right click and do render tags and then display and let's do lines. So now we can see through it. So that's the outer membrane. Now I also want to create a center. What we're going to do, we're going to have 2 XP emitters. One is going to be emitting and being on the membrane, and one is going to be in the center of this sphere. So let's create another sphere, and this sphere can be really small. Let's set it to say 1. And I'm also going to make the outer sphere a child of this sphere. And I'm going to call this one sphere inner. And I don't want to see this inner sphere, so I'm going to turn off the visibility. Now, because I did that, the child, the outer sphere, is hidden as well. The gray means that it's just a default state, so it's going to look at the parent, whatever they have here. But if I set this to green, we can now see the outer sphere again. And to this inner sphere, I just want to add a little bit of movement. So let's do animation, and let's do a vibrate tag. And enable position and rotation. And let's do 75, 75, 75 for the position. But a lot slower, so the frequency of 0.1 should do. And let's do rotation 90, 90, 90. And the same thing, let's do this really slow. So now they're going to just kind of travel around a little bit. So that's it. So that's the base setup. So now we're going to add particles to this. So let's start by going to X particles and let's bring in a system. And I want to have them above this XP system. So always a good idea to have objects that you reference come before it in the hierarchy. So in this XP emitter, which is going to be XP emitter outer, let's go to the object tab, and instead of an ellipse, let's do object. And then the object is, of course, going to be sphere outer. And it doesn't really matter if we emit from the polygon center or polygon area, because these particles are going to travel around the surface or along the surface anyway. So let's keep it at polygon center. And let's go to the emission tab. And I just want to have it in one go. So shot, let's set the emission mode to shot. And I'm going to do 200. And when they're born, I don't want them to have any speed. So you know what? Let's pull this over a little bit so we can see what it actually says. So let's set speed to 0. And the radius of 3 is fine, but let's set some variation. Let's do 2. So they're not as the same size. So let's play this back and see what we've got. So we got some particles that are emitted, but they're not moving because the speed is 0 and they haven't been told to follow that surface yet. Let's do a few more things first. Let's go to display. And instead of dots, let's do a circle. Circle is a really good mode because it shows you the actual size of the particles, but it's still really fast to display in the viewport at the same time. And under the color mode, instead of a single color, let's do a gradient random. And I'm going to pull out these knots. And let's make this guy just like a pinkish color, some sort. Something like that, a little warmer, maybe. And this one can be in a similar hue, just much lighter. Maybe something like that. I think that should be good. So if we play this back now, we have this. So to have these particles travel along the surface, we're going to use the follow surface modifier, which is a really useful modifier in so many situations. So XP follow surface. And in this modifier, we need to tell it, what do we want to follow? Well, we want to do sphere outer. And if we play now, you can see that they do follow now. Now, pull is essentially a strength slider. So I'm going to pull that to 100, although they're already sticking. Now, we want these to be inside of the membrane, not on the outside. So the offset here, if we pull the offset and play this back, now we can control how far away from the surface they are, and then we can create some variation as well. Now, that's obviously not what we want. I'm going to set this to -12, and I don't want to have any variation, so let's set this to 0. And that means they're just going to sit inside of that object, although they are not, because the distance here is 10, so some are being left behind. We'll play this again. See that these guys are being left behind? And to fix that, we can work on this. The distance, if I pull this up, this basically tells how far away from the surface that you can pull the particles in towards the surface. So if we have this at a really big number, like this, and that should fix that. Oops, let me go back. So now you can see they're all traveling inside of this surface. Now, could be nice to have a little bit of variation, but you want to be careful so it's not traveling outside of the membrane. So in my case, I'm just going to leave it at 0. Now, we're going to come back to friction as well. This works in conjunction with other deformers as well. So it's better to illustrate that a little bit later on when we have some more deformers. So they're just static. They're following the surface, but they're not doing anything. So let's bring in some movement. And we can just go to modifiers and just do a standard first, a XP turbulence. And this is going to be a little too intense. And the scale is not really what we want. So what we can do is just simply take down the scale to, say, 15%. And now they're moving around a little bit. So now, with some turbulence, what we can do, let's play this back so we can see what happens. There's no friction now. If I pull the friction up, you can see they stop. So we do want to find some sort of medium where they move a little bit, but not too much. So I'm going to go to, I know 27 is going to work pretty well. And I also want them to interact. with each other. So I want the particles to interact with each other. So I'm gonna enable some dynamics. I'm gonna go to dynamics and let's stop this for a second. And let's do XP constraints. And what we want to use in the XP constraints is forces. So let's enable that, particle forces. So in the forces here, we have forces limit, attraction, and repulsion. Now, attraction and repulsion is pretty self-explanatory what they do. Let's just play this back and see what we get. So let's bring up attraction a lot to like 100. So you can see we have these little clumps here. So the attraction is the amount of attraction, but we also have this radius is, it needs to be below this radius to work. So if I go maximum 100 here, now they're all gonna be interacting with each other or be attracted to each other. But if I bring this down to say like a 2, you can see they're gonna float apart because now it's only allowed to be attracted within 2 centimeters. And then we also have forces limit, which limits how many can be interacting at the same time. And I'm going to lower that to 9, so it's not as intense. Now, of course, we also have repulsion, so they can be attracted, but they can also be repulsed. And they can be repulsed within this radius as well. So finding the perfect formula here, you can really go down a rabbit hole because this could be a lot of fun. Let me set the attraction to around 60 and let's bring up the radius to, I think, 8. And inner, we can bring this up to, say, 8 as well. In fact, let's bring this up to 15. And then let's not have so much repulsion. We can have around 25. Something like that, perhaps. And I'm just going to make this radius a little bigger than the radius for the attraction. You really have to experiment. This is a lot of fun. I could get stuck here for hours just playing around. But I think this is pretty good. You could argue that it's a little too erratic in there. So what we can do, we can also add some viscosity. And this just gonna make it a little bit more like gluish, like glue, more sticky. And what we can do is we can perhaps take down the stiffness a little bit to say 20, 19 is what I used in the original example, I think. And let's bring up the connection limit a little bit. So it just slows things down. Now, if you disable that, you can see that this is what it's going to look like without, and this is what it looks like with. It just looks like they're in liquid. It's more viscous. So I think that's going to be pretty good. And I'm going to be happy with this result. We can always go back and tweak. So that's the base setup for the outer particles. Now I want to have them create the tendrils or the strands inside of this membrane. So how are we going to do that? Well, we are going to bring in another emitter. So I'm simply going to duplicate this emitter. Let's call this one XP emitter. And let's do inner. And let's go to the display tag. And let's switch the color. Let's do like a greenish color. And then the color mode, let's set this to just single color. And let's use the same color so we can tell them apart. Let's just play this back to see what we get. And of course, they take on all the attributes of the emitter that I just copied. So first, let's go to the Object tab and switch to the sphere's inner for the object. And let's see what that does. So now they're born in a different place, but they're still affected by the modifiers. So one thing that I find very useful when working with several emitters and modifiers is that in the emitter, we have a modifiers tab, and the mode is normally set to exclude. So that means that all the modifiers, everything that you bring in is automatically going to affect this emitter or all emitters. And especially with complex scenes, I find that it's better to use this mode, include. So you have to manually drag all the modifiers that you want to have it being affected by. And it's just easier to keep track of things that way. At least I think so. So now that we press play, you're going to see that it's not going to be affected by XP constraints or the turbulence or the followed surface. So that's working pretty well. Now there is one little problem. Let me hide this outer emitter, and I'm going to hide this sphere as well. And if I play this back now, I don't know if you can see it. We actually turned this off, so of course you can't see it. Let me bring this back on so we can actually see the sphere that we made at the beginning. So the sphere is what's actually causing the movement, but right now, the particles aren't traveling with the sphere. They're just static. They're just stuck there. So to fix that, what we can do is in the inner emitter, we can go to Object, and then we can say Stick Particles to Source Object. And now that we play it back, it's going to follow. So with that solved, let's go and hide this again and bring back the outer sphere. Like so. And let's turn on this emitter. So now we have this. So how are we going to connect them now? Well, we're going to use the electrics object. So let's go to generators and choose generator. Let's do XP electrics. So in the mode, we can do two object if we want, but we are going to do particle to particle. And I'm going to use the outer emitter as the main emitter, and then the destination emitter is going to be the inner. And we have these kind of lightning bolts in there, and they're flickering. So let's fix a few of these settings. First of all, we don't want to have any flicker. And I don't want to have any forks here as well. And so it's a little better. But I'm going to go to the deviation tab. And first of all, if I take this down to 0, we're going to have straight lines. But I want to have a little bit of deviation. So we can control kind of how curly these are by bringing this up. We can also control it with the deviation weight on the X and Y. So if I set this to 20 and then 20, and then this one has less of an effect. So something, I think something like that is going to be pretty good. Now, I don't want to use any displacement here, so I'm going to set this down to 0. Let me zoom in, but I do want to make sure that we have it enabled, because if I disable it, you can see, or you can't see because I haven't gone to the spline here. Let's go to the spline tab first, and instead of linear, let's do Bezier. There you go. And let's just do natural and 8 points. So now if you go to deviation, if you disable that one, you can see that now you can see the stepping on those splines. So let's make sure we have this one enabled. And let's go back out. So that looks pretty good. We are not going to render the center particles. We are only going to render the outer particles, the membranes, and then the strands here. And I mean, I'm happy with this. You could always go back and tweak this, but this is the main setup. And the next step is to render this. So before I render, let me just show you some of the setup of the scene elements that I already have. So let me hide the XP system for a second. And let's turn this on, or let's unhide this. And just see what we have. So I have a camera set up. And then let me zoom out. I also have 3 lights. I have some debris. I don't know if you can see that on the screen recording, but I have some debris, which is just a cloner with a platonic and then some random position and scale. And that's animated slightly. And then I also have 2 more particle setups, which are identical to what we just set up. So let me unhide those. Like so. And that's just for scene composition. I also added a Redshift environment on top of these three lights, where I have some just some volume scattering. So scattering amount of 0.3 and just this kind of bluish, greenish environment. So let's start. Let's go make sure that we have under render settings. I am using Redshift and I am using, I think this is 3.0.16. It may not be the latest, but it's one of the latest releases. So if there are some features you see here that you don't have, then this is not one of the officially supported versions yet. But this is the one that I am using. And let's close this and let's go to the camera. And by the way, I'm using an 80mm camera. And let's look through it. And let's go to Redshift, render view. And let's just start this and see what we get. Okay, so what I'm going to do first is I'm going to hide the scene elements. And I'm going to go to sphere outer. And I'm going to hide it for a second. Let's work on the particles and the strands first. So I already have the tentacles. I'm going to bring that to the electrics. And to render this, we also need to add a Redshift tag. So I'm going to right click and say Redshift tags and the Redshift object. And the Redshift object needs to be a curve of some sort. I'm going to use capsules. And 0.1. And let's just create some variation in here. So I'm going to hold down Control and make another anchor point there. And just have it a little thicker in the middle. Something like that. Just so it's not so even. And let's just take a look at this material. It's really, really simple. And let me pull that over. So this is just a standard. This is just a standard Redshift material. I have left pretty much everything at its default. And then I'm using a vertex attribute. And then I'm using the curve position, which enables us to color it along the spline. So it's different. The beginning and the end can have different colors. So I've piped that into one ramp, which is just this white to pink, purple. And then I've added another one, which have similar colors. And then I put them both into a color mix. And I'm blending between them with this just standard noise, just for some variation. And then I've put them inside of a color correct, which just makes them a little warmer. And that's it. And then for the particles, let's do, this is the RS particle, which we're going to put on the XP emitter outer. And to render that, we also need to have a Redshift object tag. So let me just control drag that to the outer emitter. We only need one of those guys. So here we need to enable under the particles tab. Let's enable particles by using an optimized spheres. And I am going to use 0.1 for that as well. So they're really, really tiny. And if I go in and look at this material, this is also really simple. It's simply just going to create Redshift and then materials and then a particle. So if I open this, and let me pull that over. So when you do that, you have this minus the color correct. I just added one color correct in the middle here. I just changed the hue a little bit and the contrast, make it a little bit warmer again. And that's piped into an incandescent with an intensity multiplier of 1. And this is getting the color data from the particles. So that's it. So those materials are already pre-made, but let's make the membrane from scratch. But let me take this material just so you can see where we're going with it. So this is what we're gonna create. Let me actually show it as well. So we're gonna create something similar to this kind of transparent, I don't know, bubbly membrane looking thing. So let's see how we can build it. Let's build it from scratch. Let's delete that guy and create Redshift materials, a material, and let's put that on the outer sphere and start the render view. Let me go. Okay, so we need some space here. Let's see if we can work the space issue out here a little bit. Move this over somewhat. So the first thing I'm going to do in this material is that I am going to start with a custom, or not a custom, I'm going to start with a preset of glass. So now it's going to be transparent. And I am going to go down to the IOR and just make it 1.3 so it's closer to water. And then I'm also going to enable, if I go a little further down, I'm going to enable this thin walled. And that kind of turns it into like a bubble or something like that. So that's going to be the type of material. And I also want to add some coloring to this. And we're going to add the coloring on the coding channel. And the way I'm going to do it is by using a Fresnel. And I'm going to pipe a Fresnel into the color and into the transmittance of this. So this is like a fake thin film shader, if you wish. But let's add a Fresnel. And let's pipe that into the coding. So coding general, code color. And then let's also, oops, try that again. Let's do coding advanced, code transmittance. And let's first go into the material, and to see anything, we need to bring up the weight. And I'm also going to do some roughness. So 0.21 I did for roughness. And I'm going to make this a very low IOR, so 1.02 or something like that. And I'm going to bring up the thickness, and we're going to lower this later on, but this is just so we can see clearer as we build. So I'm going to set this all the way up to 5, which is obviously not at all what we want. But just for now, so we can see a little bit better what's going on. So if I go into the Fresnel itself, if you want a more physically accurate Fresnel, then you should use index of refraction. I am not going for physical accuracy at all, so I'm just going to turn that off. And then now we have facing color, which we can see, and then the perpendicular. Fresnel is the fall off of the reflection towards the edges based on the viewing angle. So these are going to be interacting based on how the fall off is pushed now. So you can see that the fall off is changing. We can see more of the center now. So what I'm going to do is I'm going to pipe in some colors into both the facing and the perpendicular color. So let's go and let's get a ramp. And let's start with the facing. So let's go general fall off color and facing color. And let's swirl this down, and I'm gonna make, let's pull this over so we can see both knots. Get blue color, something like that. I think is pretty good. Something ocean-like. And this one I am gonna have more towards the green, not white, but fairly low in saturation. Something like that. And now I'm also going to bring up the noise amount, and that can kind of give you some swirly colors. I don't know how well you can see, it's a little dark, but that gives us some swirls, which looks kind of nice. So I'm going to do 1.6 around. And then I'm going to control drag this to make another one. And this we're going to pipe into the perpendicular color. And I'm going to use the same base here. I'm just going to shuffle these colors around a little bit so it's not exactly the same. I'm just trying to create some variation. And then I'm gonna right click and say double these knots and move them around a little bit. And just shift the hue a little bit, create a little bit of variation, maybe a little darker. And then I'm gonna double these knots again and just move them around. That's too greenish, perhaps. Okay, I think something like that. And then I'm gonna go back to the Fresnel, and I'm gonna set this to a really low value. I'm gonna set this to 0.5. And I don't know how well you can see, but there are some swirls there of the color. And now let's go back to this material, and instead of 5 for the thickness, let's set this to a more reasonable value, like 0.2. So we can still see it, but it's a lot more subtle. Now I also want to have some more kind of like frosted glass, so it's not so clear. So let's work on that next. And the way we're gonna get that is by going to the base properties here. We're gonna pipe a noise into the reflection weight and the reflection roughness. And let me actually pick a different frame where we can see more of the tentacles. Let me close this. I want to get a better frame where we have an even spread of the tentacles. Perhaps something like that. Let's start this again. Okay, so that's better. Okay, so let's go and let's get a noise. And I'm gonna use a maximum noise. And let's pipe that into reflection. We want the weight. And let's do it also to the roughness. And you can already see what's happening there. But let's pipe this directly into the output so we can see the noise. So I want to make this bigger. So inside of this noise, let's make the overall scale 10. And this is not the noise that I want. Let's do Luca. I like Luca. And can try a different seed. Maybe that. And let's bring down the white here towards like 60, 70. So it's not as intense. Let's do that. So that's good. So now let's see what we get when we pipe this into the actual output. So you can see that wherever the noise is active, we have some transparency and we start seeing some frostiness on the glass, which looks a lot nicer. At least I think so. Now I want to accentuate this a bit more. So I'm going to pipe a ramp between the noise and the roughness just so we can control it and accentuate this a little bit more. So let's add a ramp. And let's get the noise into that ramp. And then let's bring that to the roughness, or the reflection roughness. So now this ramp can control how much we get. So if we pull this black towards this way, we get less. But if we go the other way, we're going to increase this. So there's no right or wrong answer here. It's all to taste. I think that's perhaps too much. But again, that's to taste. So maybe something around there is what I would say is good. We can go one frame forward if I hit G. So, I mean, you can tweak this a lot, but I am gonna be happy with this. So what I'm gonna do is I'm gonna close this and just make this a little bigger. Let me just show you one thing for the render settings. If I go back to my render settings, I am using under this new version system, and then we have experimental options. We have enable automatic sampling. So I have that set up, and if you do that, then basically Redshift takes over the sampling for you. You don't have to go into the individual sample sliders and set them. Redshift does it for you. I mean, it's still an experimental feature, so I'm sure it's going to get better. But once you enable that, then the adaptive error threshold slider here becomes like a noise slider. How much noise is acceptable in here? So if you have this at a higher value, this is going to be more noise. It's going to render faster. And the lower this is, the cleaner it's going to be. But of course, the longer it's going to take to render. So I just wanted to show you that because I've started using that as pretty convenient. So let's do one final bucket render, like so, and let's see what we get. So it looks a lot better when it clears up a little bit. And I don't know if you can see it here, but we have these little color strands which comes from the noise in the ramp. So that's the final result. If you come up with something cool using these techniques, just send me a link. Or if you have any suggestions, just drop that in the comments. All these project files are available on velocitypeak.com. I'll see you next time.